work together. First, at the edge of the SDR, bottom right in this diagram, we deploy edge access switch EA to connect with external router. EA is a simple commodity switch, works at layer 2 and does layer 2 isolation for different tenants or ISPs. Data plan is responsible for high performance packet processing with large 14 tables. It communicates with EA via layer 2 VXLAN tunnel and communicates with the VPC via TGRE tunnel. TGRE means Tencent GRE. We have just customized the standard GRE for some special purpose. The data plan is also responsible for redirecting signaling messages like BGP and BFD to the routing plan. In addition, the VXLAN fabric has been built among the whole SDR domain for traffic engineering. Okay, the routing plan is responsible for peering with the external routers for routing information exchange. And the BGP message are carried over layer 2 VXLAN tunnel between external router and the SDR. So the routing plan and the external router are able to establish BGP session directly. On the top, the orchestrator acts as a global controller. It is responsible for distributing operators' configuration requests to corresponding SDRs. And orchestrator is also responsible for collecting particular traffic scheduling requests. Some of them may form the external management system and synchronizing them to corresponding SDRs. Control plan acts as the local controller. It is responsible for programming configuration from orchestrator to corresponding nodes of the local SDR. Apart from that, control plan has provided distributed message queues in order to efficiently synchronize dynamic forwarding rules among data plan cluster and the routing plan cluster inside one SDR. So we can see that these different kinds of components are loosely coupled with each other. We can easily add or remove one instance into each kernel component independently for scaling or upgrade purpose without affecting other components and affecting the whole system. And meanwhile, from the outside network perspective, SDR just behaves as a role of router. Now let's revisit the customer access scenario I described earlier and look at how SDR works for them. On the top of this diagram, we deployed SDR as PL gateway, private LAN gateway. Customer router is connected to Tencent EA switch. Different tenants are isolated by layer 2 networks. And the BGP session is directly established between the PL gateway and the customer router. On the bottom, we deployed SDR as VPN gateway. For VPN gateway, IPsec tunnel will be deployed first to provide the security for the traffic traversing the internet. On top of that, BGP session is established between VPN gateway and the customer router. Both the routing information from PL gateway and the VPN gateway will be propagated to VPC side. Usually, VPC will choose the optimal route, which is from the PL gateway to send the traffic back to the customer side. Once PL gateway fails, VPC can quickly switch to use the VPN route to send the traffic back to customer side. The PL gateway and the VPN gateway can back up each other. Sorry. By deploying SDR, we can easily interoperate with both the traditional customer networks and SDN-based VPC networks. Moreover, SDR can support up to 10K tenants per tenant rate limiting and the statistics for billing. All is